Hey, what's going on here, guys? I got another build video today. This one is for PinkyPi Pro. The hardware is about the same as the original PinkyPi with the exception of some of the standoffs, screws, and the battery itself. You'll see here the Pro version includes several extra buttons, start, select, ABXY, and a left and right trigger, as well as a larger screen size. First thing, we want to get started with the charging circuit. We need to replace resistor 3 with another value resistor. This changes the charging voltage so you don't damage your battery. Details are in the link in the description. There's a full parts list as well as details for what resistors you'll be replacing and where to purchase the actual items themselves. As you can see here, I used a heat gun to remove that resistor. I'm now applying a little bit of solder flux before we put the new resistor in place. With the new resistor in place, I apply some heat. Everything looks good, the resistor is in place, there's no solder bridges. We can now move on to the next phase. This is the screen itself. As you can see, the battery fits perfectly in between the pin headers and the left and right trigger buttons. In our scenario, we're kind of limited on space, so I want to go ahead and cut off the JST connector so I can directly solder the battery into the battery charging unit. We'll get the pads tinned to hook the battery up, as well as the output that goes into the power switch and the Raspberry Pi. With the battery now in place, we can remove the charging circuit and start focusing on the Raspberry Pi. There are 2 pins on the back of the Raspberry Pi for 5 volt and ground. This is where we're going to run the power output from our charging circuit to. So this is actually what's going to power the Raspberry Pi device from the battery. Next, we're going to go ahead and start on the audio portion. This is the 10K potentiometer. As you can see, several of the pins are bent up. Again, these will be in the link in the description. First thing we want to do is hook up the resistor from our parts kit. This is going to create a low-pass filter, which will block out some of the hiss and feedback noise you get in the audio equipment. Next, we solder on the capacitor to the end of our resistor. An extra wire for ground, and an extra wire for the audio signal. I've added an extra wire to the resistor and capacitor strand. You can see there that orange wire, that will go to our ground as well. Once it's soldered in place, I'll replace my heat shrink tubing to cover everything up. Using some heat, I go ahead and seal up the heat shrink. I want to avoid anything shorting out, so I try to cover it as best as possible. And we should now be able to apply a little bit of super glue to the potentiometer itself and secure it to our parts shelf. You want to try to seat it back as far as possible so it doesn't interfere with the case itself. Now we can go ahead and hook up some of the connections into our audio amp circuit. The purple and brown wires are a combined ground wire coming from our audio potentiometer. And the orange wire is our audio input line. We'll feed that into the left channel. And then we can bridge the ground between the left channel and the ground for the 5-volt power. I'm doing my best to make sure all the wires are tucked away nice and neat and out of the way, as space is very limited inside of this case. Now that our ground wires are hooked up, we can solder into the left output and get ready to connect our speaker. And the speaker is now in place. The part shelf is done for now. Let's go ahead and focus back on the Raspberry Pi unit itself. Here we want to solder up a 5-volt positive and a 5-volt ground. This will power our audio amplifier. Be careful to get the wires as close as you can to the base of the pin header so there is room for the display hat to seat properly. Double check everything to make sure everything is nice and secure, and we now have 5-volt coming out of our Raspberry Pi to power our audio amplifier. Now we can run our 5-volt positive and ground wires into the audio amplifier. And this portion of the part shelf is done, so we can start securing the base. You first want to run the screws up through the base of the Raspberry Pi unit. On the front half is where we'll use the 3D printed standoffs, then the parts shelf, and then our smaller threaded standoffs go on top. Once everything is secure and in place, including the battery and battery charger, we can mount the power switch. I used a couple of dabs of super glue on each ends of the power switch to secure it into place. We can then take the power switch and connect that up to the battery charger and Raspberry Pi. Ground from the Raspberry Pi goes directly into the battery charger itself. The output from the battery charger goes into the switch, and from the switch back into the Raspberry Pi to control power off and on. Again, be very careful in here, space is limited. With the power switch connected, we can hook up the output, positive and negative, into our charger. And get ready to hook up the audio wire. This is the audio output coming from the Raspberry Pi on GPIO pin 18. With the audio output now connected to the Raspberry Pi going into our potentiometer, we can secure a few items into place and mount the audio amplifier. I added a couple of drops of hot glue to the battery charger and wiring to hold everything in place. I then hot glued the speaker in front of the speaker output, as well as added some glue to the power switch. We want to test fit the battery and screen together. And screw in our top screws to make sure everything seats properly. This is also a good time to test power of the device. And with our PinkyPi Pro pre-built image, everything loads. You can find the PinkyPi pre-built image on our website, crackedconsole.com. It is available for free. The last part is to place our buttons into the top half of the case and bolt everything back together. The case is together, we can put on the joystick top and consider this project done. I hope you enjoyed. Be sure to leave a comment if you've created one of these yourself. Join our message forums and share the photos of the device that you've made. Also be sure to subscribe and share with your friends. Thank you very much.